All right, here's part 2 of the inverse trig worksheet from class today. In this this video, I'm going to work on the second page here. On the second page, we have two different sections. This first section asks me to simplify, and it makes the comment that my answer shouldn't have any trig or inverse trig functions in it. So this arc sine, it's got to go, and this tangent, it's got to go also. So how am I going to do that? Well, I'm going to take advantage of the fact that tangent of an angle is equal to the sine of that angle divided by the cosine of that angle. So what can I do with this? Well, the cosine of the arcsine of x is going to take some work. But the sine of the arcsine of x, that's just x. So that's good. I'm almost done. I just need to figure out what goes right here. To figure out what goes right here, I take advantage of the fact that sine squared, maybe I'll write this above because I'm going to reference it over and over again. This is called the Pythagorean identity. Sine squared plus cosine squared equals 1. So if sine squared plus cosine squared equals 1, cosine squared has got to be equal to 1 minus sine squared. So cosine of x, maybe I'll spread that out a little bit. So cosine of x is equal to the square root of 1 minus sine squared x. And yes, there should be a plus or minus in there, but the pluses and minuses will take care of themselves with the restrictions that I put on these inverse trig functions. Okay, so if the cosine of any angle is equal to, so let's see, cosine of arc sine of x, which is what I have in the denominator here, that's really just the square root of 1 minus the sine of the arc sine of x. And then this whole thing is squared. And the nice thing about this is the sine of the arc sine of x, that's just equal to x as we saw over here. So what I have written on this side is just the square root of 1 minus x squared. And so I can take that and put it in here and get my answer. This simplifies to just x over the square root of 1 minus x squared. What about this one here? Tangent squared of some angle minus cosecant squared of some angle. Well, there's a few different ways you can do this. Option 1. Because sine squared plus cosine squared is equal to 1, I could divide both sides of this identity by cosine squared. I'll write it out. Sine squared over cosine squared plus cosine squared over cosine squared must be equal to 1 over cosine squared. All right, if this equals this divided by cosine squared equals this divided by cosine squared. That's what I got right here. But sine over cosine is tangent, so what I have written here is tangent squared of x. Cosine squared plus cosine squared is just 1. 1 over cosine is secant, so 1 over cosine squared would be secant squared. So tangent squared x minus secant squared x. Now if I subtract this over to this side, I can subtract the 1 over to this side. That's equal to negative 1. So I don't even care that it's tangent squared of this weird angle and cosecant. Shoot, I thought that was secant. Maybe I'll change it to secant. Done. Secant squared of that angle. I don't care that those are those strange angles. No matter what they are, this identity tells me that the answer has got to be equal to negative 1. Probably didn't see that. You weren't expected to. So you also could have done this by saying that tangent is sine over cosine. So I have sine of arc sine of x. I guess this is option 2. Over the cosine of the arc sine of x. That whole thing is getting squared because it's tangent squared of this guy. Minus secant squared, but secant is just 1 over cosine. So secant squared would look like that. I got to simplify this thing. Well, that looks really bad, but it's really not because sine of arc sine, just x. Cosine of arc sine, as I saw above, is the square root of 1 minus x squared. So what I have here is this thing squared. And over here I got 1 over cosine of arc sine. Again, I've already shown that that's 1 minus x squared square root 1 to, so I have 1 divided by that thing, and remember that whole thing has to be squared. So I got x squared over 1 minus x squared. If I distribute this square in, it cancels out this square root. Minus 1 over 1 minus x squared. Wait, I got a common denominator, so why don't I just subtract the numerators? I got x squared minus 1 over 1 minus x squared. Huh, weird, those are pretty similar. I wonder if they simplify at all. In fact, they do. If you pull out a negative 1 from this, it changes into 1 minus x squared. If you don't believe me, take this negative 1 and distribute it through. That'll make this negative 1 and this positive x squared. Negative 1, positive x squared. 1 minus x squareds cancel out, and I get the same answer of negative 1. I thought that was clever. Maybe you don't. Solve these equations. Okay, so I put these at the end in case there's anybody who sped through this worksheet too quickly. Basic idea here is I want to solve for x. So okay, isolate it. Let's maybe divide both sides by 4. And I got sine squared of 3x plus pi is equal to 3/4. Okay, so if I want to isolate the x, I'd like to get rid of the sign. But before I can get rid of the sign, maybe I should get rid of this squared right here. So let's take the square root of both sides of the equation. I get sine of 3x plus pi is equal to plus or minus the square root of 3 over 2. So what I can now do is say that 3x plus pi is equal to the arcsine of root 3 over 2, or 3x plus pi is equal to the arcsine of negative root 3 over 2, because I had this plus or minus right here. And the nice thing about arcsine of root 3 over 2 and arcsine of negative root 3 over 2 is I can figure out what those are equal to. Might have already done it. Arcsine of root 3 over 2, anywhere? Anywhere? I don't know. I don't want to look anymore. I'll just figure it out. Arcsine of root 3 over 2 is asking me what angle between here and here leaves me with the y-coordinate of root 3 over 2. Looks like that's right here, pi over 3. So this is just equal to pi over 3. And over here, kind of the same logic, arcsine of negative root 3 over 2 is asking me what angle between negative pi over 2 and pi over 2, when I take the sine of it, will I get negative root 3 over 2? And the answer to that is negative pi over 3. So I have these two equations right here, which I'll take up here to solve. 3x plus pi equals pi over 3, and 3x plus pi equals negative pi over 3. If I subtract pi from both sides, I get 3x equals negative 2 pi over 3, because I got 1 pi over 3 minus 3 pi's over 3, so I got negative 2 pi over 3. Divide by 3, you get x equals negative 2 pi over 9. Over here, if you subtract pi, you get 3x is equal to negative 4 pi over 3. So x is equal to negative 4 pi over 9. Turns out there's more answers. We'll learn later how to find more answers. Essentially what it comes down to here is when I take this arcsine here, I'm restricting my possible answers, because arcsine will always give me something between negative pi over 2 and pi over 2. But really the sine of a whole lot of stuff will be right here. I can take as many laps around the unit circle as I want. So we'll learn later in the class how to find more solutions, but for now, here's the two that we can find using inverse trig functions. This problem, same basic idea. In fact, I think it's the exact same problem. Whoops. Guess this problem's gone. All right. Here's the last problem here. This one, again, I don't expect anybody to be able to solve this, but there is a way to solve this. It turns out this factors. This factors into 2 sine of 2x plus pi plus 1. I think that's right. Times sine of 2x plus pi minus 1. That's not going to work. All right, so this was supposed to factor like this. I got negative 2, positive 1. Yeah, actually, let's make this minus that. So there you go. You can see this is why I make these videos. Usually I do them in enough time to get all my answers right, but now I'm just kind of checking my answers while I'm watching a basketball game. So I'm not going to go ahead and make a new video. I'll just show you behind the curtain how I screw stuff up all the time. This right here, this problem that I meant to start with, factors to this. And once it factors to this, you can set both sides of the equation. You can set this equal to 0 or this equal to 0 because I got something times something equals 0. And then I'll be able to solve those. If you have trouble with the factoring, maybe I'll explain this step up here. Explanation. The way you can factor this is you can substitute. So let's let the sine of 2x plus pi equal y. So then you come down here and you're like, all right, 2, instead of sine of 2x plus y, sorry, 2x plus pi, I'll write y. So 2 of those things squared, I got 2y squared. Minus y minus 1 equals 0. Well, this thing factors. Maybe this looks a little bit more familiar to you. Start out with something like this. 2y times y gives me 2y squared. To multiply to negative y, I got to put a positive 1 somewhere and a negative 1 somewhere. And I want, when I FOIL things back out, to end up with negative y kind of in the middle here. So I'm going to throw my negative 1 over here and my positive 1 over here. But playing the role of the y is this sine of 2x plus pi. So if you take this right here and you copy it, except everywhere you see a y, you write in sine of 2x plus pi, you'll get what we have here. Anyways, once you get to this step, you can say that 2 times the sine of 2x plus pi plus 1 equals 0, or the sine of 2x plus pi minus 1 equals 0. Same thing you do after you factor when something's set equal to 0. Set each of the individual factors equal to 0. This is something times something else equals 0. And the only way you can multiply together two numbers and get 0 is if one of those two numbers are 0. So either this first number, this thing here, must be 0, or this thing here must be 0. And you can solve these equations. Subtract 1 from both sides. I got 2 sine of 2x plus pi is equal to negative 1. Divide by 2. You got sine of 2x plus pi is equal to negative 1/2. Take the arcsine of both sides. 2x plus pi is equal to the arcsine of negative 1/2. The arcsine of negative 1/2 is asking me where from here to here is the y-coordinate equal to negative 1/2. Right here, the y-coordinate is equal to negative 1/2, so negative pi over 6. So I got 2x plus pi equals negative pi over 6. Subtract pi from both sides of the equation. You get 2x equals negative 7 pi over 6. Divide by 2. You get x equals negative 7 pi over 12. Do that same thing over here, except now you're adding 1 to both sides of the equation. You got sine of 2x plus pi equals 1. So 2x plus pi is equal to the arcsine of 1. What angle between negative pi over 2 and pi over 2, when I take the sine of it, do I get 1? Well, sine is the height. The height is 1 when I go straight up, when the angle is pi over 2. So 2x plus pi equals pi over 2. Subtract pi from both sides. You got 2x equals negative pi over 2. Divide by 2. You got x equals negative pi over 4. Much like above, other solutions are possible. But finding more solutions is a topic for later in our class, so I'll leave it right here and just say those are the two solutions that we can find using our inverse trig functions, I suppose, is one way you could word that. And I'll end this video here.